Hi Jatea, thanks for sending in your question about analyzing relationships between points, lines, and planes in a figure. Now, I actually get this question a lot, and so I really hope that this helps. The part of the tricky thing here, well, first of all, we want to see that this is a three-dimensional picture. So a plane is a flat surface, and this plane is called plane X, and it's kind of like a piece of paper. This piece of paper is going up, and to me it looks like it's going through the computer screen, however you want to look at that. And then this line AC is going through the plane. Almost looks like it's going through at a perpendicular intersection here, but it doesn't actually say that, but it's going through the plane. It looks like the line EF coincides inside the plane X. Okay, so it's, I'm using the word coincide loosely there, but it's kind of lying on the plane there, right inside that plane. Okay, now we're going to get into some of the nitty-gritty with some of this in just a moment, but some of this can be a little tricky with what we're thinking these definitions are. So here we go. This first part, we're supposed to check all statements that are true. So it also tells us specifically which points up here lie in plane X and which points do not lie in plane X. So it says another name for plane X is plane BCF. So you do need to name a plane with 3 letters, and those 3 letters have to, and when I say letters, I'm really talking about points. We need to name it with 3 points. B, C, and F need to be in the plane, and they can't all be just on the same line. Okay, so looking at B, C, and F, now C is not on plane X, so that would not work. We would need points like B, F, and D. If they had said B, F, and C, and E, if this had been an E here, that still would not be true because it's not enough information to name the plane. All 3 of those points lie on the same line, so that's not enough to name plane X. It would need to be something like B, F, and D. Then it would have been true. Okay, so not true for the first one. Now let's look at points A, B, and C. Are those collinear? A, B, and C. Yes, they are. They all lie on the same line. That's what collinear means. They lie on the same line. Now, another thing I want to bring up about collinear points is any 2 points are collinear. So if they had said, are points A and E collinear? Even though they didn't draw the line through A and E, we actually can draw a line through A and E. You can draw a line through any 2 points. So if they ever ask you if any 2 points are collinear and they get named 2 specific points, the answer is yes. It's kind of tricky because they didn't draw the line in for us, but we can draw a line through it. Okay, so let's look here. Lines AE and DE intersect. So AE, again, they did not draw the line, but we can draw the line through AE, and then it's asking if that line and the line DE, which was not drawn for us either, do those 2 lines intersect? Yes, they do. When we draw the lines in, those lines would intersect. So just because it's not drawn doesn't mean that it can't be that way. All right, let's look. Points A, let's get a new color here. A, D, E, and F are coplanar. Well, no, because E, D, and F are coplanar, but A is on a different plane, so that's not true. Now, like what I was saying about lines and 2 points creating a line, any 3 points can create a plane. So even if they had left off, say, F and said A, D, and E, okay, so let me see here. Oops. A, D, and E. Let's say they only gave us those 3 points. We could draw a plane through those 3 points. It would be something kind of like this. It would not be parallel to plane X, but we can always draw a plane that will have all 3 points inside the plane. So if they give you just 3 points and ask if they're coplanar, the answer is always yes, because any 3 points can make a plane. Okay, but they didn't do that. Whoops. Let me see if I can delete some of these here. Okay, They didn't ask us that, so that one is not true. Let's see the next one. Point D and the line AB are coplanar. Point D and the line AB are coplanar. Nope, the line AB is going through the plane. It's not lying on the plane X. So those are not coplanar. And then none of these are true. Well, obviously we have two that are true. So I hope that helps. You can rewind this at any time to see kind of the examples of what I was talking about. I tried to cover a variety of different things, even ones that are not on this problem. So good luck with that and let me know how it goes.